about related postulates. So first, what is postulate? A postulate is an idea that is assumed to be true. Guys, we're going to have an example. So as you can see, there are two protractors here. So how can we prove that these protractors form a circle? This figure proves that the circle measures 360 degrees. The semicircle measures 180 degrees. It means the semicircle is also the half of the circle. The measure of the central angle is equal to the minor arc and vice versa. What is central angle? When two chords meet at the center of the circle and two endpoints are on the circle, an angle formed is called central angle. So next, what is an arc? An arc is an unbroken part of a circle. There are three types of arcs: the minor, the major, and the semicircle. First example.
In this video we're looking at finding the length of an arc. So an arc is part of a circumference of a circle. So in this case we've got a semicircle and the arc is the curved bit. So it's the bit that's part of the circumference of the circle. So in this case, when we've got half a circle, all we've got to do is find the circumference of a circle and half it. So if you remember the circumference of a circle is pi times the diameter, or 2 times pi times the radius. So pi times diameter, so that will give us pi times, the diameter is 20 in this case, pi times 20, and because I've got half a circle, I just need to half my answer. So in this case, pi times 20 divided by 2, because it's half a circle, not the whole circle, will give me an arc length of 31.4 centimeters to 1 decimal place. So that's easy when we've got half a circle, but what if we've got 35 degrees of a circle? So what if we want to find out this arc here? This is called the minor arc of the circle, because there's also a major arc which I could have done around that side, but we're going to work out the minor arc in these questions, the smaller one, the one enclosed by this sector here. So I've got 35 degrees of the circle, and you should know a whole circle is 360 degrees, so all the way around is 360 degrees. So when I want to know what fraction of the circle I've got, how much of the circle I've got 35 out of 360. I've got that fraction of the circle. So I've also got that fraction of the circumference. So whenever we say of, we mean times. So I've got that fraction of the whole circumference, which is pi times the diameter, or 2 times pi times r, pi times the diameter, which in this case is 20, because the radius is 10, so the diameter is double that, which is 20. Then I can type this into the calculator, and if I type it in and then press the SD button, that's going to give me my arc length. So in this case I've got 6.1 centimeters to 1 decimal place, and that is the length of this minor arc here. Okay, so let's look at these two examples. Again, we're going to work out the length of the minor arcs. So this length and this length. So in this case I've got 40 degrees, so that means I've got 40 degrees out of a full circle, so 40 out of 360, and then times the whole circumference, which is pi times diameter, which is 20 again. So that's what I'm going to type in the calculator, and to 1 decimal place, that's 7.0 centimeters to 1 decimal place. In this case, I've got 110 degrees, again, out of a full circle, times pi times the diameter, which is double the radius, so 16. And then that's what I type in the calculator, and it's going to give me 15.4 centimeters to 1 decimal place. Okay, here's 2 questions for you to try. Pause the video and give them a go. So we're going to work out again the minor arc, that's this length, and this length. So we've got 130 degrees in this question. Again, 130 out of 360. That's our fraction of the circumference we want, and it's of the whole circumference, which is pi times the diameter, which is 18. You could, of course, use 2 times pi times the radius. Here instead, it gives you the same answer. So that's what we're going to type in the calculator, and that's going to give us 20.4 centimeters to 1 decimal place. Over here I've got 20 degrees out of 360. That's the fraction of the circumference I want. And pi times the diameter, which is 12, double the radius. That's what I'm going to type in the calculator. And I get the answer of 2.1 centimeters to 1 decimal place.